is effectively a scholar of football. It's the same way as studying any other subject, learning a new language, anything like that. You build up experience, you learn the basic rules of grammar in the different words that are available to you. So in football terms, that's going to be the skills, then putting them into a match situation. And so as you become more fluent in the language, you don't need to think about it as much.
So Ronaldo's vast experience gives him the ability to intuitively read the game under normal conditions. But what if the conditions are very far from normal? Can Ronaldo still hit the back of the net if all the lights are turned off and he's in complete darkness?
Okay, what we're going to do, we're going to have Andy feeding the balls in as if it's a cross, and then sometime in the ball flight, the lights are going to go black, so you won't be able to see anything at all. We're expecting you to be able to put the ball in the goal. That's what we're hoping will happen. We're hoping that you'll have picked up some advanced cues from Andy's body position, the shapes, the positioning of his feet and his hips, and therefore will be able to tell exactly where the ball's going to go and get yourself in the right position, even though you can't see it.
Okay.
Taking Ronaldo on in this seemingly impossible test is an amateur footballer called Ronald.
Come and join me, Ronald. Ronaldo. So we've got Ronald in here, same age as you, roughly the same height. We're going to use Ronald as a comparison and see how he reacts doing this same test.
Ronald is going first.
Dark! Light! Light!
So what does the night vision reveal? Ronald misses the ball by quite a way. Perhaps not that surprising. But can Ronaldo do any better?
I hope to do once.
Dark! Light!
Hey, that's one straight in the bag.
The night vision replay shows how differently Ronaldo performs. To confirm that wasn't just luck, another attempt.
Dark! Light!
Love that.
Be careful.
And the replay?
How hard is that?
It's difficult because it's changed a lot.
Yeah.
Because you are focusing on the ball, and after non-light, you have to try to memorize the ball.
Human reaction time is about 200 milliseconds, and by 500 milliseconds, Ronaldo's subconscious has interpreted Andy's body language, worked out which direction the ball will go in, calculated its speed and trajectory, and then programmed his body to reach it at the optimum moment.
Love that.
It's almost as if they're doing maths in their head, even though they wouldn't be able to describe it to you. You could see from their performance that Ronaldo saw the first part of the ball flight information. He'd picked up information from Andy kicking the ball and was able to move his body into the correct position. This is because he's processed the information, he has experience of where the ball is likely to go, he's able to analyse all that as it's coming towards him and therefore connect successfully with the ball.
Love that.
Ronald, on the other hand, doesn't have the same level of experience. He would have watched the ball flight. It's likely that he will just have had his eyes on the ball instead of picking up any information from Andy himself. And then when the lights go down and it's black, he's kind of stranded in no man's land a little bit and just has to do his best to react, but is naturally going to struggle with that.
So far, the lights have been shut off when the ball is in midair. But now, the lights will be turned off just at the moment Andy kicks it. Can Ronaldo score with only Andy's body language to go on?
Here you go, we'll get one. We good?
Yeah, good.
Okay, Ronaldo.
Dark! Light.
Light. Aye. Ronaldo, fully. What was that, a shoulder? Tack. Great finish, great finish. That was a great finish.
This is great, because I imagine the ball is coming. I scared to go with the face, so I go with half chest, half shoulder, and then put the ball inside.
Quality, great finish. So Zoe, tell me, how difficult is that? I mean, the last one, when we adjusted the time of the lighting.
Yeah, it's so difficult. They've done studies like this using computer simulations, so you watch it on a computer and just have to say where the ball's going, and from them they can see that elite athletes can tell much earlier where the ball's coming from, but to have to actually produce a physical response when a ball is flying at you, then it's really
We know
good skill.
physiologically that nerve cells that fire together wire together. If you practice something over and over again, those nerve cells have a long-term relationship. If you get angry on a daily basis, if you get frustrated on a daily basis, if you suffer on a daily basis, if you give reasons for the victimization in your life, you're rewiring and reintegrating that neural net on a daily basis, and that neural net now has a long-term relationship with all those other nerve cells called an identity. We also know that nerve cells that don't fire together no longer wire together. They lose their long-term relationship because every time we interrupt the thought process that produces a chemical response in the body, every time we interrupt it, those nerve cells that are connected to each other start breaking the long-term relationship. When we start interrupting and observing, not by stimulus and response and that automatic reaction, but by observing the effects it takes, then we are no longer the body, mind, conscious, emotional person that's responding to its environment as if it is automatic.
The most sophisticated pharmacy in the universe is in here.
There's a part of the brain called the hypothalamus. And the hypothalamus is like a little mini factory, and it is a place that assembles certain chemicals that matches certain emotions that we experience. Those particular chemicals are called peptides. They're small chain amino acid sequences. The body's basically a carbon unit that makes about 20 different amino acids all together to formulate its physical structure. The body is a protein-producing machine. In the hypothalamus, we take small chain proteins called peptides, and we assemble them into certain neuropeptides or neurohormones that match the emotional states that we experience on a daily basis. So there's chemicals for anger, and there's chemicals for sadness, and there's chemicals for victimization, there's chemicals for lust. There's a chemical that matches every emotional state that we experience. And the moment that we experience that emotional state in our body or in our brain, that hypothalamus will immediately assemble the peptide that then releases it through the pituitary into the bloodstream. The moment it makes it into the bloodstream, it finds its way to different centers or different parts of the body. Now, every single cell in the body has these receptors on the outside.
And one cell can have thousands of receptors studding its surface, kind of opening up to the outside world. And when a peptide docks on a cell, it literally, like a key going into a lock, sits on the receptor surface and attaches to it and kind of moves the receptor, and kind of like a doorbell buzzing, sends a signal into the cell.
It's party time!
A cell with the same attitude and the same chemistry over and over again on a daily basis. When that cell finally decides to divide, when it produces a sister cell or a daughter cell, that next cell will have more receptor sites for those particular emotional neuropeptides and less receptor sites for vitamins, minerals, nutrients, fluid exchange, or even the release
During
of
this
waste products
important
or
period of brain development, billions of brain cells called neurons send electrical signals to communicate with each other. These connections form circuits that become the basic foundation of brain architecture. Circuits and connections proliferate at a rapid pace and are reinforced through repeated use. Our experiences and environment dictate which circuits and connections get more use. Connections that are used more grow stronger and more permanent. Meanwhile, connections that are used less fade away through a normal process called pruning. Well-used circuits create lightning-fast pathways for neural signals to travel across regions of the brain. Simple circuits form first, providing a foundation for more complex circuits to build on later. Through this process, neurons form strong circuits and connections for emotions, motor skills, behavioral control, logic, language, and memory during the early critical period of development. With repeated use, these circuits become more efficient and connect to other areas of the brain more rapidly. While they originate in specific areas of the brain, the circuits are interconnected. You can't have one type of skill without the others to support it. Like building a house, everything is connected, and what comes first forms a foundation for all that comes later.